Okay, everyone, ding, 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 ding. That's like wedding toast getting attention, but everyone was really quiet immediately. Thank you. My name's Katie Greenaway. I'm the Graduate Research Coordinator for the school, and it's my great honour to chair this special colloquium, which I'd like to open by acknowledging the traditional owners and custodians of the lands that we're gathering on today and that we work on, the Wurundjeri people of the Kulin Nation, and pay my respects to elders past and present, and I think particularly relevant to today's session, pay my respects to emerging leaders within First Nations communities as well, because the emergence of or continuity of identity and leadership is really how groups of all kinds thrive and continue, and that's exactly what we're here to celebrate today. Our own emerging leaders within MSPS. This is a special colloquium focused on highlighting the work of the winners of our Postgraduate Student Research Award that was awarded earlier in the year, but we usually take time at the end of the year to reflect on and celebrate the excellent work that our graduate researchers have been producing. And I think all of our students do really wonderful work. It's something that we're extremely proud of within the school. And we designed this award to really highlight or spotlight some particularly outstanding performers in that category. So we have two speakers today. We actually had four mentions within this category. Two people weren't able to make it today, Uandoan and Shima Ruhi, but certainly please look up their excellent research, which is wonderful as well. But to start us off in this session, we're going to hear from Lindsie Arthur, who is the winner of the Postgraduate Student Research Award, and she'll tell us all about the research that got her here. So thank you so much, Lindsie.
Hi, thank you everyone for coming. I'm just going to jump straight into it, but thank you for such a lovely introduction. So I'm not sure if I know everyone here, so I thought I would just very quickly introduce myself. So my name's Lindsie. I am a social psychologist, and I'm broadly interested in things related to gender, biology, and pretty much any kind of social phenomenon. I recently completed my PhD with Candice Blake, and that research was interested in understanding the role of hormones and hormonal contraceptives on a range of outcomes. So the work that I'm presenting today is an extension of that work. It was ideas essentially that were developed during my PhD, but that weren't included in my final thesis. But I'm also employed currently at the Melbourne Business School, and I do research on sexual harassment and diversity programs, and I'm very excited to be starting a postdoc in the field lab in 2026. So you can't get rid of me just yet. So I thought that it might be helpful to just give a little bit of background on behavioural endocrinology, which was sort of the main theoretical or technical background from my PhD. So the endocrine system is a network of glands and organs that interact to regulate a whole lot of automatic processes. So this includes things like reproduction, sleep, growth, metabolism. The list is extensive, and hormones are really important in this process because they're the chemical messengers that send information through the bloodstream to different parts of the body that essentially coordinate these processes. Behavioural endocrinology is interested in understanding how hormones influence behaviour specifically. It's really important to understand that hormones don't directly cause behaviour. This is a common misunderstanding of people from outside of the literature, but what they do is they make things more likely, they make certain responses or feelings more likely in particular situations. So for example, there's quite a lot of research that suggests that cortisol is important for preparing us for stressful situations. It helps us to stay alert, whereas hormones like oxytocin are thought to support things like trust and bonding. But these effects are really heavily dependent on things like the context that we're in, our own personal goals, and the social setting. So when we're talking about these hormone effects, it's really important that we're not talking about fixed drivers. We're talking about this bidirectional tendency that influences the way that we behave. Now, one area that's received an extensive amount of research when it comes to hormone and behaviour effects is the menstrual cycle. So in adult women, the menstrual cycle is characterised by changes in steroid hormones, and in particular estradiol and progesterone, with estradiol being the main kind of estrogen in reproductive aged women. So the follicular phase typically sees low levels of progesterone, while the blue line here, estradiol, rises in the lead up to ovulation. We then have ovulation, which is when we're most likely to conceive. If we're thinking back to like high school sex ed, this is when the egg is released from the fallopian tube or into the fallopian tube. But it's also the only time when estradiol is extremely highly elevated, and there's a lot of research that focuses on this area. We then have the luteal phase, so after ovulation, when we see progesterone increase for the first time, and estradiol also remains quite high. You don't really need to know the details of the different profiles, except to understand that there are different phases, and that those phases are thought to be associated with different kinds of behaviours. So there's a fair bit of mood research, for example, that looks at things like elevated positive affect around ovulation, or conversely a depressed state or more negative affect during the luteal phase. In my own work, and this was the focus of my PhD, I was interested in shifting levels of competition across the menstrual cycle. So here we found, we mostly found in my research that the start of the cycle is associated with elevated competition, whereas the later part of the cycle is, we see less competitive motivation and behaviour. So the main theoretical argument for this work is that we have a finite amount of energy that needs to be allocated to different things at different times in the cycle. So in theory, if we allocate some energy or most energy towards competition during the follicular phase, then that means that we have less energy for other things, but that also means that during other times of the cycle, we may have less energy allocated to competition. And where my PhD started to go at the end was I became interested in what's happening if competition is high during ovulation, what's high during the other periods of time. So what I began to become interested in was this idea of increased social connectedness or increased affiliation motivation. So this idea that we seek more connectedness, and here you can see from my very high-tech imagery, we're allocating more energy here, possibly because of high progesterone, towards affiliation and therefore less competition, okay? But the issue with this research, or one of the main issues, is that it's very common to find null effects and failed replications. There are lots of possible explanations for this, including things like poor research design, small sample sizes, but there's something that's actually not discussed very often, and I think that it's extremely important. And this is the fact that we tend to treat all naturally cycling participants, so those not using hormonal contraceptives, we tend to treat them as one homogeneous group. Okay, so this is problematic for obvious reasons. These are pretty complex models usually. We're usually testing people at multiple time points across the cycle. And so there are reasons why we don't tend to include trait level variables in these models. There is research that does things like controlling for age, ethnicity, socioeconomic status. But there's also pretty good reasons to think that not all women experience the same level of fluctuation across the cycle, but this is currently not represented well in the models that we're using. So this is really interesting to me and potentially problematic because we already know that people vary a lot in their sensitivity to hormone change across the cycle. So for example, there are some women that I'm going to call low sensitivity women who experience very little fluctuation across the cycle. These are the kinds of people who might be surprised every month when they start bleeding again and they say, oh, I didn't realize it was coming. At the far other end, we have this high sensitivity group. So these people are extremely sensitive to their cycle. They can usually tell you with pretty high accuracy when they're going to get their next period, and also where they're at throughout the cycle. And then we have this pretty big spectrum of sensitivity in the middle, okay? So people who feel like maybe a little bit, but not really. Now, this idea of hormone sensitivity is not new. The hormone sensitivity hypothesis argues that some people experience more intense changes at these big shifting periods like puberty and menopause, whereas we also know from like month-to-month cycles that there's a lot of variability. So people with PMDD or premenstrual dysphoric disorder experience extreme fluctuations across the cycle, so much so that there's a clinical diagnosis for the 4 to 7 days prior to their onset of their next period. So for these women, there can be extremely high negative consequences, including higher suicidality just in that 4 days before the cycle starts. Most people experience a more moderate level of PMS, so this is like a bit of bloating, maybe a little bit of a headache, maybe a slight mood adjustment. And then finally at the other end, we have these like almost no symptoms across the cycle. But what happens when we bring all these people into one group is that our current models treat all these different people as one group, and therefore we're assuming relatively consistent psychological change across the cycle. So what I wanted to do was, instead of collapsing across hormone sensitivity, I wanted to understand whether we could include this variation in our models. And so to do this, we decided to include hormone sensitivity as a moderator of our cycle-related variables. So hopefully you've still stayed with me. But with all of that background information, I had to explain what is previously done before I can explain how what we're doing is novel. But basically, the aim of the current study was to understand whether hormone sensitivity moderated the effect of cycle day, so what day each participant is at in their cycle, on these measures related to social connectedness. So to test for hormone sensitivity, we used a measure of premenstrual symptom severity as a proxy for this hormone sensitivity outcome. Then what we wanted to do was to see whether or not, if people have stronger cycle phase effects or higher hormone sensitivity, does this mean that they have does this lead to a greater effect of cycle day on affiliation and attachment outcomes? And then at the other end, if we have weaker cycle phase effects, does that lead to a weaker effect of the cycle? So just a couple of key methods things. We had about 250 people, all cisgender women in our studies, and this was a mobile phone design collected from the US and the UK. So basically participants answered questions about their affiliation. It was part of a bigger study, but we're interested in the outcomes to do with affiliation and attachment. And they answered these questions every day, and we had a really high response rate. So most people answered for more than 28 days. So it's one of the most, thorough studies in this area. We had, as I said, this premenstrual symptom questionnaire. We had these daily measures for state attachment. So we had anxious, avoidant, and secure. And then we had 2 measures of how much people either want to affiliate with others or how sensitive they are to being excluded. Okay, for our analyses, this is where it's a little bit novel. We use generalized additive models, and I'm going to focus on this for a moment because it's really important for understanding the results. Okay, so for traditional multi-level models, these assume a linear relationship. So in traditional work, we would look at something like the linear effect of backwards counted day on something like affiliation motivation. They're really good for testing things like fixed effects, but they might miss more complex patterns, and for my work, they're likely to underestimate or misrepresent effects if there is something there, but it's non-linear. So instead, we look to use generalized additive models, which allow for data-driven, smooth functions for non-linear relationships. But what that means is that they're well suited to continuous predictors like backwards counted cycle days, so where they are in the cycle, but they can be modeled to interact with these more dynamically with these cycle variables. And then also importantly, we can combine them with random effects to make sure that we're accounting for within-person nesting. So basically, it just means that they're better at capturing these non-linear hormone sensitivity effects for our cycle variables. But I want to just warn that I'm new to these models, so if I've misunderstood something critical, I'm very open to your feedback. Okay, this is the last complicated thing that I'm going to explain. So before I talk through the results, I just wanted to explain the table really quickly. So here on the far left, just like with a normal regression analysis or a multi-level model, we have main effects for backwards counted cycle day, which is just a complicated way of saying where they're at in their cycle. And then we've got this hormone sensitivity measure, and then we have the interaction between the two. We also have this EDF variable, which tells us how complex the shape is. So values close to 1 are linear and values higher than 1 are non-linear. We then have the F value, which tells us how important the term is, and then we've got the the P value, which is what we would normally understand a P value to be. So it's telling us whether or not the F value is statistically significant. Okay. So here I looked at avoidant attachment across the menstrual cycle to determine whether or not this pattern depends on hormone sensitivity. So for avoidant attachment, we don't see a clear overall effect of backwards counted day. So avoidant attachment doesn't consistently rise and fall across the cycle. We do, however, see an effect of hormone sensitivity. So we see a strong linear effect such that people with high hormone sensitivity are more likely to be avoidant attachment regardless of the day. We then, and really importantly, we have a significant interaction between cycle day and hormone sensitivity. So this means that the pattern of avoidant attachment across the cycle differs depending on their level of hormone sensitivity. You can see it here in this figure. So the bottom here, the x-axis, is the backwards counted cycle day. The reason I've put a green box around it is that on your far left, those days begin to have far fewer data points because most people have finished their cycle by then. So focus on the green boxed area. But here you can see that the dashed line indicates some variation, but that for different levels of PMS, we're seeing quite a bit of variation that wouldn't be captured with our previously existing models. A similar pattern comes out for secure attachment. So we see that in this case, backwards counted day is significant. So there is variation across the cycle on average. Hormone sensitivity is also significant. So here it's the inverse, that if you have high hormone sensitivity, you're more securely attached. But again, we see this interaction appearing. So again, there's something happening where hormone sensitivity is affecting the strength of the backwards counted day effect. For anxious attachment, we don't find the interaction. So although there is, according to this, although it's not obvious in the figure, we've got this backward counted day where it's indicating some variation, but hormone sensitivity and the interaction are not significant. And then similarly for desire to affiliate, we find that although there's no effect of the cycle and there's no effect of the interaction, we find that hormone sensitivity on average matters. So maybe there's some relationship between this hormone sensitivity and like desire for closeness with others. And the same is true with sensitivity to exclusion. Okay. So here's the overall picture. Cycle day doesn't affect everything, but it does appear to affect attachment anxiety and attachment security. Hormone sensitivity shows some relatively consistent or linear effects across most outcomes, which suggests that there may be some kind of relationship between hormone sensitivity and social outcomes. And then really importantly, the interaction effects where we're combining cycle phase and hormone sensitivity, we're finding that they do show up for avoidant and secure attachment, which tells us that there is something here that we wouldn't be detecting if we weren't accounting for individual differences. So in terms of the theory, this matters a lot because cycle effects aren't universal, and it's possible that a lot of the null effects or null replications are missing something in the way that they're looking at their data as opposed to the way that they're asking the questions, which has been the common critique. But also, this applies to lots of people in that if you expect some kind of nonlinear relationship in your data, GAMS might be an appropriate way to capture that. And it is a little scary going into the GAM world, but it has been extremely informative in my thinking about these kinds of problems. And then finally, from a practical standpoint, this is important because the public conversation about menstrual effects is everywhere right now. There's a lot, there's apps, there's podcasts, there's books, but a lot of this work is relying on meaning, messages that are oversimplified and a one-size-fits-all. So hopefully my work can bring a more dynamic and accurate piece to this conversation. And that's all I have. Thank you.
Time for some questions.
Yeah.
Great talk, beautiful coverage of the really, as you said, quite a complex topic, and I think it was refreshing to see how clearly it could be explained for a novice like myself. I was just wondering whether this is a kind of technical question, but hopefully it's interesting. The participant ID effects that you showed, which were really extremely non-linear, if I understood correctly.
Yeah.
I was wondering whether they refer to variation in the slope of backwards counted day, or if they're about variation in the intercept in your model, if there is one.
No, my understanding is that it's the linearity of the slope rather than the intercept. So what I'm currently trying to do is work out exactly how to model that in a way that makes sense, and just determining whether or not we should also include an interaction between the ID and backwards counted day. That's a little bit more technical, but I'm trying to understand what the right way to model this is. This is my initial modeling and what we've the way really helped me think about it. But the more that I understand GAMS, the more that I understand that little decisions like that can make a really big difference to the outcome, and hopefully it doesn't change my results too much. Yeah. Who knows?
So those effects mean that even after you account for that hormone sensitivity, there's still all this variation in that slope of where people are in the cycle predicting.
Yeah, which also makes sense because I'm like a dog with a bone with this thing, in that the way that people experience their cycle is extremely variable. There is so much variation. Some people actually experience extremely depressed mood around ovulation for reasons that we don't really understand. And so when we sort of lump everyone together with these books, or we say you should feel like this at this time, it's really confusing for people who don't feel like that. Or I'm trying to, there's so much more variability beyond this hormone sensitivity measure for sure. Yeah. Yeah.
Thanks, Lindsie. Just to echo what Pete's saying, just a really lovely talk and clearly expressed for someone who doesn't know anything about attachment, doesn't know anything about hormones. I have a question about this idea of hormone sensitivity and sort of what you mentioned, all this complex variability across people. And what I kind of wanted to get your thoughts on is how complex is hormone sensitivity? Is it it's treated as a kind of univariate type measure here? Some people are more sensitive, some people are less sensitive. To what extent is that a simplification of what's going on? Is it possible to be sensitive to estradiol but not to progesterone? What does that landscape look like? Yeah,
I think definitely. There's this new, since we ran this study, there's this new sort of model of hormone sensitivity called, I think it's -MC, and basically it says exactly that. Some people are more sensitive to estradiol, others are more sensitive to progesterone. But at the moment, there's just not really a measure that gets at that. I think it would be really important to develop something like that to show that there are different profiles, because it has really important clinical significance as well. With lots of women miss a PMDD diagnosis because it doesn't fit this very classic 4 days before I'm extremely emotional, but there is still a lot of variability. So I think definitely that's the case, but there's just not really a way at the moment to measure that effectively.
Is it a biological, is there a way of measuring this biologically that maps onto the subjective experience, or are they
No, yeah, that's what makes it so complicated. So the hormone sensitivity hypothesis originally thought that it was too much of one hormone or not enough of something that was causing the effect. But actually, when you look across all different populations, people have really similar, there's a lot of variability, but that doesn't explain the differences at all. There's more neuro research that's looking at a receptor difference. So is it more estradiol receptors? Is it less progesterone? Or is there something, allopregnanolone, which is a derivative of progesterone, could also be having an effect. There's just so much we don't know in this space. And yeah, unfortunately, it just makes it so hard if we're like at the end of the line trying to work out the outcomes when we don't even know what's happening internally. Yeah, but thank you.
Maybe just one, if I can. I'm really
Yeah.
curious about your thoughts. This is potentially going beyond your data, so
Yeah.
feel free to tell me it's not relevant. But I was interested in you saying that it's such a unique and bespoke experience for everybody, and these one-size-fits-all, approaches could be invalidating or kind of unuseful. What do you think is the logical end game for, if you note that there's all of this, between person variation in how these are experienced, how can clinicians or other people tackle that approach? What's the answer if there isn't a one-size-fits-all approach?
Yeah, I think this is purely speculative, but I think for me it's an education thing. Like the number of people who, like, I'll just be at a dinner and I'll get cornered and they'll be like, this is my hormone experience. And just saying to them that everyone's experience is different, and just because this is your experience doesn't mean it's bad or wrong or unhealthy. But it would, the same is true for miscarriage. Like we don't know, medicine doesn't know what is a quote unquote normal miscarriage. And that's crazy to me when so many women experience them. So I feel like it's partly like understanding like on a scale what is typical, what is non-typical, but then also just being like, it's normal to not be like normal. Yeah, I think.
Concept in the social support literature that you should validate first and then
interesting.
offer like cognitive support or problem solving later, and it sounds like maybe.
Yeah, that feels right in this space because we just don't know. And I think I have a lot of very like hippie women's circle friends who I love dearly, and I love this space, but they are often telling people like, you should change your life in this way to fit your cycle. But if that doesn't fit for someone, then I think then that's also a problem. Yeah. Yeah.
Yeah. One question, you sort of touched on this briefly, and I think you might be thinking about it already, so partly why I wanted to ask. So one of the points of individual difference, you spoke about hormone sensitivity. Another one is the length of the cycle or its phase. And that's clearly a point of individual difference. It was there in your data. You mentioned that you're talking about modelling the back counted days slightly differently. I assume that's with an eye to looking at some of this difference in like the length of the phase?
Yeah, it's really hard because some people argue that you should standardise it, so you should just squash or extend everyone into a standard 28-day cycle. The problem that I see with that, though, is that there's information in the fact that they have a longer or a shorter cycle, and so when we standardise, we're sort of doing the same thing. It makes the model easier to interpret, but we're losing a lot of the nuanced information about like what's actually happening. Why do they have a shorter cycle? Which bit of it's longer? And so, yeah, I feel like, again, we're like trying too hard to like squash the variability into something that's easy to understand in our models. And then we lose that, we lose what's actually happening for the people who have a longer cycle. And you can see it like so clearly in the data, like when things start to go really like wonky or different is in this like extended cycle phase. Yeah. Yeah. Cool.
Great. Well,
Thank you.
We may move on to our next speaker, but just another round of applause for them. So another person who was acknowledged with the Postgraduate Student Research Excellence Award was Alblas, who's doing her PhD on personality dynamics, and was acknowledged with this award for a paper that had a really fun title of Herding Cats, which was about the relationship between understanding Big Five personality traits and reward sensitivity theory scales, which I believe we might hear a bit about or touching on. If not, we'll hear some other really interesting things. But please join me in welcoming Ali.
Unfortunately, not the paper I'm technically presenting on today, the Herding Cats paper, but it's like somewhat related. So if you're interested, there's some separate work on that as well. So hi, I'm Ali. That was a really lovely introduction. I'm a second year PhD student working with Luke Smiley in the Personality Processes Lab and Daniel Bennett in the Cognition and Emotions Lab. And today I'm presenting the first project of my PhD, which is the first 3 studies that I've run looking at whether extraversion or anhedonia predicts reward sensitivity in a probabilistic reward task. All right, so pretty self-explanatory, but I'll start with some background and then launch straight into the studies. But before we start, I guess one of the key terms that's most important to understand is anhedonia. So anhedonia typically describes a reduction in interest and pleasure from typically rewarding stimuli. So it's most typically described as a symptom of mental health disorders like major depressive disorder or schizophrenia, but it can also be seen as an individual differences trait, so something everyone experiences to some extent. So let's say we have our friend here, Jordan, someone who might not experience any kind of psychopathology, but just generally doesn't feel very excited or moved by things that they could find enjoyable. So they might not find hobbies or social events to be particularly pleasant, and not very rewarding. So it's not like they're sad, it's just that the pleasure and enthusiasm that they could feel seem to be muted, and the volume on their positive emotion just seems to be a bit turned down. So this might be someone who is experiencing a personality trait like anhedonia. So anhedonia can be measured in a lot of different ways. One of the most common ways is through self-reports, like the PID-5 or the SHAPS, with items like "nothing seems to interest me very much." It can also be measured through behavioural tasks. So the one up on the screen is a screenshot from the probabilistic reward task, which is one of the most common tasks used in this space to assess anhedonia. So this was popularised in the early 2000s, and it's one of the most common measures that we see linking anhedonia and behavioural indices of reward sensitivity. And this task is the main task that I use in the first 3 studies, so I'm going to take you through it right now. So participants' job in this task is to differentiate between 2 mouth lengths. So first they're shown this fixation cross, and then a blank face appears on the screen. And then on the face, a mouth is quickly flashed for 100 milliseconds, and it can either be a long mouth length or a short mouth length. And the point of the task is that the mouth lengths are very similar in length, and they're shown so quickly that it's too difficult to actually be sure of what you've seen. So participants are then required to respond with what they saw, and in this case, we saw the long, so we select that, and we're fortunately rewarded in this trial. However, how this relates to reward sensitivity is that it's governed by what's called an asymmetric reinforcement ratio, which means that, firstly, not all of the correct responses participants make are going to be rewarded, but secondly, one of the mouth lengths, called the rich mouth length, is going to be rewarded 3 times as often as the other lean mouth length. So we start this divide between a rich and a lean, and what this encourages is for participants to start to show a response bias towards responding with the rich mouth length that they're rewarded more frequently for than the lean mouth length. And so this task has been used quite extensively in the anhedonia space, and it's been shown that people with anhedonia don't develop this response bias towards the rich stimulus because they're not picking up on the altered reward contingencies. And therefore we see this negative relationship between anhedonia and response bias on this task. And so this is really interesting when we consider a recent study by Scott Blaine and colleagues in 2021, because this is actually challenging this finding. So they found that it was actually extraversion, but not depression or anhedonia, that predicted reward sensitivity in this task. And so this was a sample of 299 people, and they found that extraversion positively predicted reward sensitivity with a beta coefficient of 0.14, but they didn't find any evidence on the contrary for anhedonia. So this is quite interesting from a personality psychology standpoint, because there's an established tradition in personality psychology of seeing individual differences in extraversion coming about due to variation in how we process rewards. So before I take you through the theories, I'll just quickly recap what extraversion is. So it's a big 5 personality domain. I'm sure you've all heard of it, typically describing people who are more enthusiastic, perhaps assertive, and more sociable. It's also hierarchically structured, which means that we have the broad personality domain at the top, which we can measure, which then divides down into two narrower aspects, enthusiasm and assertiveness, and then that can be decomposed into any number of narrower personality traits, so things like friendliness or talkativeness. And so there have been a number of different theories dating all the way back to the 1970s with Jeffrey Gray that have suggested that variation in extraversion come about because of how we process rewards. So whilst there are nuanced differences between these theories, overall they tend to suggest that the structures and functions of the dopaminergic reward system, which are involved in how we regulate incentive motivation and how we approach rewards, the structures and functions emerge as individual differences in extraversion. And so over time, this thinking has led to the reward sensitivity idea of extraversion becoming the most dominant theory of extraversion in the literature. So you can see here, in 1999, when Depew and Collins published their paper, it actually started, this theory overtook the previous arousal theory of extraversion. So given, firstly, the importance of this finding for both the extraversion space, so it supports the extraversion reward sensitivity theory, but also in the clinical literature, it's starting to cast doubt on the PRT as a measure of anhedonia. We wanted to see if we could confirm their results. So we started out with 2 replication studies, firstly in a student sample and secondly in a general population. So in our first 2 studies, we ran the same probabilistic reward task that I showed you before, with 3 blocks of 100 trials. And we also expanded the breadth of the measurement of our self-report questionnaires. So I won't take you through this in too much detail, but we assessed anhedonia with 7 different scales. Higher scores on these scales indicate higher anhedonia. And we also included a larger breadth of extraversion measures. So we measured all the way from the domain through to the facets, and then we included 20 facet scales as well. So Blaine and colleagues were a community sample, and we had 2 samples as well. So in study 1, we had 372 undergraduate students, and in study 2, we had 398 prolific participants. And I'll just note here that the studies were very similar. We used the same self-report questionnaires, the same task, except that the task in study 2 was made slightly harder just because accuracy in study 1 was very high. So that's the only difference, but I can go into that further if you wanted to know more. And the main aim in our samples was to ensure that we had an adequate enough sample size to ensure that we had good power to detect the regression coefficient of 0.14 that they found in this initial study. So we pre-registered 2 hypotheses. So for extraversion, we predicted that broad extraversion would positively predict reward sensitivity, both across the task and in later blocks of the task. And as you'll see in a second, we also found that there was no relation with anhedonia in study 1. So for study 2, we pre-registered that we would not find an effect. So, okay, I've mentioned reward sensitivity a few times, but how do we actually operationalize this in the task? So there's multiple ways that we could have gone around to do this, but the most common way is looking at response bias. So this is governed in the fact that the probabilistic reward task is a task grounded in signal detection parameter theory. So here we can see that we have the distribution of the rich stimulus, and here we have the distribution of the lean stimulus. So there are 2 parameters that we can extract from this. Firstly, up the top, we have log D, or discriminability, which is a reflection of how far apart these 2 distributions are. And secondly, down the bottom, we have response bias, or log B. And that's a reflection of where participants place their decision criterion, so how much evidence they need in order to respond rich if they've seen the rich stimulus. So here we can relate a movement in response bias, a positive movement in response bias, to moving their decision criterion to the left, which means that they need less evidence to say rich. And this relates to a higher hit rate, so getting the rich stimulus correct, but also a higher false alarm rate. So they say that they've seen the rich stimulus, but it was actually the lean. And it's this measure of response bias, log B, that we are most interested in. It's also the classic way that response bias is operationalized, or reward sensitivity is operationalized in the task. So the second way we were interested in looking at reward sensitivity is by using an existing reinforcement learning model. So I'm not going to take you through all the parameters, but I can if you are interested later. except to say that one of the benefits of doing this is that we can disentangle components that otherwise get conflated in response bias. So here we can pull out these two parameters, learning rate, epsilon, which reflects the speed at which the reward affects participants' behavior. And secondly, rho, reward sensitivity, which is a measure of the internal worth of the external reward. Okay. So before I get into like the nitty-gritty of the self-reports, just we're wondering whether the task actually worked. So looking at response bias development over the task, in both studies 1 and 2, the participants did develop a response bias across the task. So you can see that the task was performing as you would expect it would. By study 3, participants had a strong response bias. You can also see that in study 2, the response bias was much stronger, and that's likely a reflection of the fact that the task was more difficult in study 2. So participants had less certainty in their responses, and they were relying on things like bias in order to make their decisions. And in order to answer or address our hypotheses, we ran 2 structural equation models using maximum likelihood estimation, and these are the models that were specified in the Blaine study. So the first model, we are regressing our latent construct, here anhedonia, onto latent reward sensitivity. And in order to specify reward sensitivity, we use response bias from each of the blocks as indicators of latent reward sensitivity. Model 2 is largely similar, except in this case, we're using response bias in block 1 as a covariate. And this is because we assume that participants come in with a baseline level of response bias. So instead, we're partialing out response bias in blocks 2 and 3 as a measure of reward learning. So the models are largely similar, but just that's the way they differ. And it's this regression that we're interested in. So starting with anhedonia, did latent anhedonia predict reward sensitivity? And you can see here that in both studies 1 and 2, for both models, latent anhedonia did not predict reward sensitivity. So considering that Blaine also found that anhedonia did not predict reward sensitivity, and then we also found this in study 1, before we ran study 2, we pre-registered that we would not find this. So we pre-registered that anhedonia would not predict reward sensitivity for either model, and we ran Bayesian structural equation models to test this. And from the results up on the screen, you can see that we supported H2A and H2B in study 2. Following this, we wanted to look at specific anhedonia scales. So like I said before, we included 7 different scales, and we used these as the items to specify the latent constructs. So here you can see highlighted in red are the significant predictors. Overall, the effects are quite small and the p-values for these are quite large. And perhaps most interestingly is that all of these are in the opposite direction than what is expected. So they're both small and in the opposite direction. So opposite direction, higher anhedonia is associated with higher reward sensitivity. So moving on to extraversion now, we hypothesized that extraversion would be a significant predictor in both models. And you can see here that, again, for both studies 1 and 2, for both models, extraversion was not a significant predictor, so we didn't find support for either hypothesis. I won't go too much into the specific details of the scales, but we then looked at both the aspects and the facet scales. And you can see here there was only one significant predictor, which was BFAS enthusiasm in study 2. Again, very small, and again in the opposite direction than expected. And then that's the same story for the facets. So here, highlighted again, you can see there were only 3 significant predictors, small and in the opposite direction. So now moving on to our model results, we ran simple regressions with our self-report scales predicting both of the parameters, but starting with reward sensitivity, we only found that there were 2 scales that were significant negative predictors of reward sensitivity, and this was only in study 1. This wasn't consistent again in study 2, so very little signal here. And we did the same for learning rate. You can see there are a few more of these significant relationships popping out, but there was only one that was consistent between the studies. So this was warmth, and that's saying that higher warmth is associated with a shallower learning rate, again in the opposite direction than we'd expect. Again, very small effect and also a very large p-value. So just to summarize studies 1 and 2, we didn't support our first hypothesis, as we didn't find that broad extraversion predicted reward sensitivity for either model. And interestingly, we did find that anhedonia did not predict reward sensitivity for both of these models. And so we did replicate Blaine, and this was quite interesting because for a long time, anhedonia has been thought to be able to be measured behaviorally using the probabilistic reward task. So our findings seem to be quite problematic for the literature. And so in light of this, we decided to run a meta-analysis of correlations between response bias and anhedonia. And so we searched various databases and came up with 30 studies that have correlated reward sensitivity or response bias in the PRT and a measure of anhedonia. And we extracted 62 independent effects, so each paper could report multiple correlations. We then ran a 3-level correlated hierarchical effects model. So level 2, we had our within study level, so this is reflective of the multiple correlations per study, and level 3 was our between study level. We then also ran various moderator analyses, so I'll pop these up on the screen. I won't go through all of them today, except to pull out 2 that I think are the most interesting. So the first is the reward type used in the PRT. So that's either whether participants were rewarded with money for correct choices or social feedback, so thumbs up or smiles, and also the sample type that they're drawn from. So whether they were from a community sample or a clinical sample with participants with major depressive disorder, for instance. And so now jumping into our results, I'll pop the forest plot up on the screen for you. Interestingly, we did actually find a marginally significant effect. So this was a meta-analytic R of -0.08, and this was statistically significant. In saying this, there was very high heterogeneity between studies, so 66.59% at level 3, so between studies. And there's also a very large prediction interval, so spanning from -0.36, or a medium to large effect, all the way up to +0.21, so a small to medium effect. And given this large prediction interval, we really can't be certain that the effect that we found is robust. And now moving on to our moderators. Overall, we found no significant moderators. And pulling out those 2 I mentioned before, there was also no significant effects for either feedback type, so not for money or social feedback. But perhaps most interestingly, you might expect this to come out only at the clinical level. So with clinical populations, there was also no significant effect there either for either population. So now to summarize study 3, whilst we did find a significant result, we're really not sure that we can consider this to be a robust effect. So I'm going to pop this forest plot back up on the screen for you now. And highlighted in yellow are the effects that are drawn from sample sizes that have at least 80% power to detect small to medium effects. I think there's 2 interesting things here. Firstly, that there's very few of them. So the vast majority are drawn from sample sizes that are very small. And secondly, it's probably a bit hard to see, but you can see that the effects from these studies are centered around 0, and also the confidence intervals overlap. So considering these more highly powered studies and not finding this effect, this is kind of reassuring to us that this may, whilst this is significant, it's likely not a robust effect. So overall, these findings really challenge the PRT as a behavioural measure of anhedonia. Okay, and to summarize the 3 studies in total, so we didn't replicate Blaine's extraversion finding, as we didn't find that broad extraversion predicted reward sensitivity in either study 1 or 2. And we really didn't find any consistent findings either for any of the aspects or the facets. Interestingly, whilst we did find the significant effects for anhedonia in our meta-analysis, we're really not sure that we can trust this. And in both studies 1 and 2, we didn't find a significant relationship. So what does this mean? Well, for the PRT, it probably means that it's a bad measure of anhedonia. If anhedonia did predict response bias in this task, you'd expect there to at least be like a small to medium effect that was coming out consistently in these high-powered studies. It might not necessarily be a bad task, though. Participants develop a response bias towards the rich stimulus. We can also extract these parameters of reward loading and reward sensitivity in these models. It might just not be a great task for pulling out specific individual differences like you might expect. And what does this mean for extraversion? Well, it's inconvenient for the literature, given that there's been about 20 years looking at how extraversion is related to reward sensitivity. In saying this, there's very little work that has looked at how extraversion is related to behavioral indices in these task paradigms. So just because extraversion isn't related to this specific task, we can't concretely say that it's not related to behavioral indices of reward sensitivity more generally, because the literature isn't there. So a lot more work needs to focus on how extraversion is related to how people behave in response to rewards. And that brings me to the end of my talk. I'd like to thank Luke, who couldn't be here today, and Daniel, because they are both my wonderful supervisors. Also, Scott Blaine and Colin DeYoung, because we were replicating their papers and they were very fantastic in providing feedback on our pre-registrations. And then, yes, everyone else was great too.
Questions for Ali?
Yeah.
Really interesting talk, Ali. I've got a basic question. The task uses a little face with a neutral-looking mouth. Is that
Yes.
on purpose because of anhedonia and extroversion, or is it just a random thing?
I think it's a random thing, to be honest. Like, I don't think it was designed to try and, because I've had the joke with Luke before, is it looks quite anhedonic, like
I was like, oh, okay. Thanks.
No, I think that's just uncanny.
It looks like a mustache. And as soon as I start thinking about it as mustaches, I find it more rewarding.
Is there a
There could be something there, I think. Yeah, I don't think it was designed with any kind of reasoning behind it. I've seen other versions of the task where they have like bunnies and kittens, and you have to pick, you have to identify which one there is more of, and then one's more rewarded. So I think like the stimuli can differ. Yeah, but I don't think I think it's just a coincidence that it's similar to anhedonia.
And I guess also in this task, which I don't know very much about, presumably there's a reason why it's only reward and not, punishment for getting the wrong answer. But that does seem like it's pushing people towards a much more liberal threshold. Why wouldn't you just say, I saw the rich stimulus so that you can get every, rich reward?
There are versions of the task where participants are punished. I guess participants will start to change their responses based on how sensitive they are to punishment. So I guess for our research, that starts to conflate reward and punishment. But I think it's difficult enough to pick up the reward contingencies. Like, I don't think if you ask participants afterwards if they thought one stimuli was more rewarded than the other, whether they'd actually consciously notice it. So it's meant to be like an implicit bias that participants show towards this rich stimulus rather than something they are like clearly seeing. So only 40%, I don't think I mentioned that, but only 40% of all trials are rewarded. And then of those 40 out of 100 trials, only 30 are for the rich and 10 are for the lean. So I feel like it's kind of mild enough that they might not actually know that there's anything going on. But yeah.
And with that in mind, did you have controls in place to make sure that people were paying close attention when they were doing the task and weren't just missing this reward component?
Yeah, we had some attention checks throughout. but I think it's quite a long task, which is something that is difficult. And I think towards the end, especially in the third block, you could just see that participants are responding with just one option. So I know in other studies they've reduced it down to just 2 blocks of 100 trials, just because of the attention that you have to sustain. Just looking at that face flashing up can be quite a lot. But yeah, we wanted to keep it as close to Blaine, so hence the three blocks. Yeah.
Great talk. Really interesting. I never thought about anhedonia as a continually, like a normally distributed or continually varying trait in the population. I've always just thought of this like a symptom of fairly severe, really, clinical disorders. So I just wondered if you could say a little bit about how it looks, the distribution of all those anhedonia measures, and also are they just really strongly inversely related to extraversion or some of its aspects?
Yeah, it's a great question. I think like probably the picture I gave of anhedonia today was quite monolithic almost. So I think like anhedonia itself can be teased into these separable components. So there's like reward sensitivity in itself, there's like reduced pleasure from rewards, but also reduced interest. So I think when you think of it as like hedonic capacity rather than an anhedonia distribution, it kind of makes a little bit more sense as a personality trait. Like you could see that like some people get a bit more pleasure out of things and some people just don't seem to find, like if I gave you $5, some people wouldn't find that to be enjoyable. They might not get any increased pleasure from it. So I think it's probably somewhat as normally distributed throughout the population as it can be. But I think when we think of like clinical anhedonia, it is this real like blunted responses to rewarding stimuli. And then on the second, about how it could be just inversely related to extroversion, that's like the next project we're kind of looking into, because in many of these like psychopathology personality models, so like things like the PID-5 or the high top, anhedonia is just presented as a facet of low extroversion, which there's not a lot of, say, certainty on that, but I feel like it is probably highly likely that it is just one of these facets of extroversion. But yeah.
Great, well, maybe we'll give Ali one more round of applause. And I also want to acknowledge all of the people who submitted and were recognised in the Postgraduate Student Research Excellence Award. I think it speaks extremely well to our school that we have so many wonderful projects that makes going through and judging these a very difficult task, but it's also really wonderful to have the opportunity to hear about the excellent work that our graduate researchers are doing. I really encourage you to go up to Ali and Lindsie after this and ask them any more questions that you might have of them, but maybe we'll just give them one last round of applause to